Just going to walk you through what GDB is. So GDB is a terminal-based debugger. It stands for GNU debugger, which GNU stands for GNU, not Unix. That's literally what GNU stands for. So on exercise 1, part 1, everyone will have to get familiar with using GDB in terminal. After this, the IDE will wrap around GDB for you automatically, and you can debug within the GUI interface of the IDE.
Okay.
I do recommend that because it will make it easier to visualize the issues your program's having. Now, if you want to use GDB to get experience with using it terminal-based, please go ahead. But just to get you started, I'm not going to do exactly what the homework says to do, but I'm going to show you guys the examples of how you can use GDB. So let me go to program 1. Yeah, and then we type GDB program 1. For some reason it stopped responding to me. That's unfortunate. So let's not use tab this time. Let's just get into GDB. So here we see GDB with all this information here. It gives you a lot of information on what's going on. If you don't want to see this information when you start GDB, you're going to use the TAC-Q option, and which just means quiet startup, which I find better. So I am going to do a breakpoint. You can either type break all the way, or you can just use the letter B. I'm going to do it on start. And start is the function that if you took assembly, you'll know that start is where the program code actually starts. So I'm going to start my breakpoint right there. I'm going to either type run or just R works too. So I'm going to type R, run. Now I'm at my breakpoint. I can type in disassembly all the way, or I can just type in disass, and it will go ahead and disassemble the function for me. You and everyone else in this class will be familiar with Intel flavor assembly. So if we type in set, let me get the command all the way, right? Set disassembly flavor Intel. I put an extra tack in here. That should not be there. It's 1S right here. And then we disassemble again. You'll see that it went from GNU flavored Intel or AT&T flavored Intel. I mean, disassembly to Intel flavored disassembly here. We can also look at information about the stack with GDB by just typing info stack. We can get what stack frame's coming up next real quick. And we press C to continue the program. Let's set a breakpoint at main. And let's continue the breakpoint here. We can do info stack here, and we can see what's on the stack right now. Just nothing else is on the stack. Now we're inside main. Info stack. So info stack, this is what I want to show you. It'll show you the arguments on the stack. So when you have a C program that's pulling in arguments from the terminal or arguments in general, it will show you info stack what the arguments are. Then we can also do info frame, and it will show you the stack frame. I'll show you where the local variables start at. Show you the argument list. It'll show you the saved registers, the instruction pointer, and the base pointer for the stack. Another cool thing about GDB, it will show you all the states of the registers. So if you type in info reg, you'll see all the states of the registers. However, if you want to single out a register, you just type in info reg, and then let's just look at REX here. It'll just show up REX, and then you can also do REX to do shorthand. Now, what I think one of the most interesting and useful features of GDB is actually looking at memory itself. So we can get a raw view of memory of where the local variables actually start here. So let's grab this address. Then we can do something like x/32x, which x is just saying, hey, look at this memory, / it's going to say, hey, I want to look at 32 bytes of memory, and I want to look at it in hexadecimal format right here. And then we just type in the memory address. If I'm not mistaken, we have to point to it with the asterisk. Okay. So that dereferences the memory address with that pointer there. So to look at it, we don't use the asterisk, we just use the address. So we can see right there is 0 1s inside the address, and we type in info frame. Again, we can see that that's arguments argc1. Okay. Trying to think of anything else useful. I don't want to do the homework for you guys, so I'm not going to use those commands, but trying to think of any other useful GDB tricks and tips. If you want to restart your program to look at registers or to look at the start of the program again, you can just press R and it'll restart the program for you. And you see I hit my breakpoint 1. Then I press C to continue. C to continue. I hit my other breakpoint here. Now, to look at your breakpoints, you can type in info break, or you can type in just info B. I'll show you your breakpoints, right? So you have breakpoint 1.1, breakpoint 1.2, and breakpoint 2. To delete a breakpoint, you can go ahead and press DL 1.1. Or let's just go ahead and type in DL1. Okay, I see. DL1, number 1, and we'll go ahead and delete both of these right here. So now if we type in info B, we'll just see that our breakpoint here is breakpoint number 2 inside the main function.
Can you add an additional breakpoint?
Oh yeah, you can add any breakpoints you want to. So if we go to info functions, you either type out the word functions or just info func. It'll give you a list of all the functions inside your program. Just continue without paging. And these are the functions that are going to be interesting to you. They're going to be highlighted yellow. And once you see they're going to be libc, main, or main. So there's your start function where the program enters. Printf. I'm failing to see the main.
Is that because you deleted it?
No. I just not seeing it on there for some reason. I'm inside the main function here. I set a breakpoint here. The main function starts at this address right here. A bunch of 5s and 17A. It's not seen in here. It should be 17A in here somewhere.
Could that be because we're inside main?
No. It just didn't get loaded as a symbol for some reason. Anyways, this is why an IDE is going to be more intuitive than using a terminal. So this is actually a perfect example of why you should use IDE in this class instead of GDB. Straight out of the terminal. But it's good to know how to use GDB in the terminal, though. And that's why I'm getting a demo over it, just in case you don't have access to an ID. Like say you're on a machine inside the cloud, just a WAS instance of Ubuntu 18.04 or 22.01, which those are kernel-based Linux servers. They don't have GUI interaction with them. So that's why it's good to know how to use the terminal tools.
Okay.
And then any other useful GDB tips and tricks here that I can think of off the top of my head. I showed you guys how to switch from AT&T flavored assembly to Intel assembly. Showed you how to set breakpoints, show breakpoints, delete breakpoints, how to run the program inside of GDB. And I showed you how to look at memory. And that's enough. And I showed you how to look at registers also. That should be enough to get you through this class if you just want to use GDB inside the terminal.
What is watch points?
Where do you see that at?
I was looking at your GDB cheat sheet.
Oh, so watch points, that cheat sheet. I'm at means an expert at GDB at all, but a watch point sounds like it's just sounds like a breakpoint. And we can actually just Google what that is. So I don't know off the top of my head.
Okay.
GDB watch point. By single stepping your program.
So it's kind of just like a break.
Right. Well, okay. So you're watching some local variable.
Okay.
So yeah, this is like watch this memory address, and it's going to print out what the memory address is, or what's inside that memory address, because it's dereferencing this memory address right here. And it's going to watch what's inside of that memory address. So that's what a watch point is. A breakpoint's when you want to break on a certain memory address with inside memory execution, so you can see the program states at that moment. And then a watch point is watching individual variables inside your program.
Okay.
What you can do with Visual Studio Code so much easier. And then let me see if this command works. Okay, no, so that's not a GDB command. This so context is a GDB command if you have the proper extensions for GDB, but we're not going to get into that.
Is there, if you end up clearing like you would normally clear in a CLI during GDB, does it end up allowing you to continue to be in the GDB, or it just deletes your breakpoints?
Yeah. So to do it, I think you would have to press Control L,
Okay.
which is CTRL plus the lowercase l. And that's actually a Linux hotkey to clear off your terminal screen.
Instead of typing in clear?
Yeah. So you want to use Control L to clear your screen inside of GDB. Just clear breaks, deletes breakpoints. Okay. Any other questions about GDB? Do you kind of understand it a little bit better?
I think so.
Okay. And then obviously there's yes, there should be. Yeah, so you can type in man GDB and get to the manual of GDB. And it'll go through like all the options for you and everything. Put that. Now, one thing I do want to show everybody. We go, so to configure GDB to always be Intel by default, you have to have a GDB init file inside your home directory or the program directory. Just go ahead and make a GDB init file if you plan on using GDB terminal with this class and you want to use Intel flavor always. Just go ahead and set this assembly flavor Intel inside of this file. And then I put an extra U in there. So when I open up GDB again, let's go ahead and run this test in GDB test. Q. It's going to be run. That's already an Intel flavor for me instead of AT&T flavor assembly, which I find Intel a little bit easier to read than AT&T. And coming from 3.11, you'll have experience with Intel-based assembly anyways.
I didn't do 3.11. I don't think.
I thought it was a prereq for this class, but you're in a different. Okay, never mind. You're gonna have different prereqs than the cyber operations students. So, have you taken any? I'm gonna go ahead. If you have any more questions about GDB, I'm gonna go ahead and end the recording.